One bird uses fire to hunt, another disguises itself as a harmless scavenger, then strikes when prey lets their guard down. And one species figured out how traffic lights work. These aren't instincts, these are calculated strategies. Here are 15 birds with the most genius hunting tricks on the planet. This owl hunts in total darkness. No light, no visual confirmation, not even a moon, and it almost never misses. Here's what makes that possible. Its wings are lined with tiny comb-like structures that eliminate sound. Most birds are noisy in flight. The great horned owl is silent, completely silent. Prey never hears it coming. That alone would make it dangerous. But then there's the feet. The pads on its feet are packed with nerve endings, the same density you'd find in human fingertips. The instant the owl grabs something in total darkness, those nerves send back a full map. Shape, position, size, the exact location of the spine, in the dark, mid-strike, in under a second. Then it crushes. The grip pressure is enough to fracture bone on contact. The prey never heard it, never saw it, never had a chance. One motion, strike, grip, kill, no light required. The fastest animal alive isn't a cheetah, it's a bird, 240 miles per hour, in a controlled dive, faster than a race car, faster than anything else alive under its own power. At that speed, the air pressure would collapse the lungs of almost any other bird instantly. The peregrine has bony ridges inside each nostril. They deflect the incoming air, reduce the pressure. The falcon breathes normally, at full speed, while everything around it is a blur. And when it hits, it doesn't grip, doesn't bite. The impact alone kills. Bones break on contact. The prey is already dead before the falcon circles back. Speed, that's the whole strategy. Speed so extreme that everything else, including a kill, becomes automatic. This bird hunts venomous snakes, not by grabbing them, not from the air, it stomps them to death. When a secretary bird finds a snake, it raises one foot and drives it down at a speed the human eye can barely track. The force? 5 times its own body weight, delivered in a fraction of a second, directly to the snake's head. If the snake isn't dead after the first hit, the bird does it again and again. And if the snake manages to strike back, the secretary bird's legs are covered in thick, layered scales. The fangs can't penetrate. It's a bird that walks into a fight with a venomous predator and wins every time. The golden eagle can kill animals many times its own size, not because it's stronger than them, because it uses cliffs. In mountain regions, golden eagles specifically target animals standing near ledges, goats, deer, chamois, and hit them from the side at speed. The blow doesn't need to be lethal, it just needs to be enough. One hit, loss of balance. The mountain does the rest. The same strike on flat ground, the animal walks away. On the edge of a cliff, different outcome entirely. What's unsettling is that the eagles don't strike animals standing in open fields. They hunt near edges specifically. They select for terrain. The drop isn't an accident. It's part of the plan. Every bird of prey on this list hunts alone. This one didn't get the memo. Harris's hawks hunt in groups of up to 6, and they coordinate with a level of teamwork that has stunned researchers since the 1980s. When prey hides in dense brush, a single hawk can't flush it out and catch it at the same time. So they take turns. One bird dives, harasses, retreats, then another, over and over, wearing the prey down, waiting for the moment it breaks cover in a panic. When it does, the others are already in position. They also post lookouts, birds stationed at height watching prey movements, while others push from the ground. The results are measurable. Groups eat more often. They take larger prey than any of them could take alone. This isn't occasional behavior. It's how they hunt every single time. This bird weighs less than 2 ounces. No talons, no gripping strength, no way to hold prey still, so it found something that does the job instead: thorns. When the loggerhead shrike catches a mouse, a lizard, or a small bird, it carries it to the nearest thorn bush or barbed wire fence and impales it. The prey is pinned. Now the bird can use its hooked beak to tear it apart without needing to hold it. But that's not even the most disturbing part. Shrikes don't always eat immediately. Individual thorn bushes have been found holding multiple prey items at once. Insects, reptiles, small mammals, all stored at different stages of freshness. The shrike remembers where each one is. It comes back for them later. It's not just a hunter, it's running a pantry. A penguin colony looks impenetrable. Hundreds of thousands of birds packed together. Every parent defends its nest aggressively. Any predator that approaches from the front will be attacked immediately. The brown skua doesn't approach from the front, it brings a partner. Two skuas target a single nesting penguin simultaneously, from opposite directions. One engages the parent head-on. It squawks. It dives. It forces the parent to focus. The moment the parent's attention shifts, the second skua moves in from behind and takes the egg. The timing has to be precise. A fast-reacting parent can stop it, so the skuas apply pressure over multiple attempts, wearing the parent down, waiting for a gap. Researchers have found that established skua pairs get better at this over multiple breeding seasons. They practice, they improve, and in colonies under heavy skua pressure, chick survival in the first weeks of life drops dramatically. Birds nest in deep cavities specifically because predators can't reach them. A narrow entrance, a sharp bend inside, it's a shelter that defeats almost any hunter. Almost. The African harrier hawk has a leg that bends in multiple directions, not just forward and backward, sideways, inward. The ankle rotates through angles that would appear dislocated in any other animal. Essentially, it has a second elbow halfway down its leg, so when it finds a tree cavity, it doesn't try to force its body inside. It just reaches in, then bends around the corner. Whatever is hiding past that turn, eggs, chicks, a roosting bat, the harrier hawk can reach it. Parent birds mob it furiously when this happens. Multiple species at once, diving, screaming. The hawk doesn't even look up. It keeps working the cavity until it finds something or moves on. No lock can stop this bird. This is the one that shouldn't be possible, because this bird doesn't just hunt at wildfires, it may be starting them. Multiple researchers in northern Australia have documented black kites picking up burning sticks from an active fire, while the fire is still burning, carrying them to unburned grassland nearby, and dropping them. Grass erupts into flames. Rodents sprint out of hiding. The kite dives straight into the chaos. This behavior has also been recorded for generations by indigenous Australian communities, the Bininj and Malak peoples, who call these birds firehawks and describe exactly this behavior in their oral records. The material carried, the pattern of fire placement relative to the hunt. If this is what it looks like, the black kite is the only non-human animal on Earth known to deliberately use fire as a hunting tool. Let that sit for a second. Small animals aren't stupid. They've evolved over thousands of generations to recognize the silhouette of a hunting hawk overhead. The shape of spread wings, the circling pattern, triggers an immediate freeze response, but turkey vultures look nearly identical from below, and vultures eat carrion. They don't attack living prey, so animals in vulture-heavy regions have learned that shape, that flight pattern equals safe, relax, keep foraging, it's just a vulture. The zone-tailed hawk exploits that learning. It has the same dark coloring, the same body shape, the same slow, rocking soar. It joins a group of actual vultures and becomes visually indistinguishable from them at height. Prey below sees a cluster of harmless scavengers. They stay in the open. Then, one of those vultures drops out of the group at full speed. Researchers are certain this isn't a coincidence. The resemblance is too precise. It was shaped by generations of selection. Birds that looked more like vultures made more kills. The current hawk is the result of an evolutionary con. This bird fishes with bait. It selects a small object, a feather, an insect, a piece of bread near a human area, carries it to the water's edge, and places it on the surface. Then it waits. When a fish rises toward the floating object, the heron strikes. If the bait drifts, the bird retrieves it, walks back, and repositions it exactly where it wants it. This has been documented across multiple individual birds in multiple countries. It's not one clever heron. It's a species-wide strategy. And here's what makes this different from normal tool use. Most animal tool use is direct. Pick up a rock, smash a shell, apply object, get result. The striated heron deploys an object, steps back, and lets the environment work. That's not just using a tool. That's understanding that a tool can do the work without you. This falcon breeds late, not by accident, on purpose. It times its eggs to hatch during fall migration, the exact window when hundreds of millions of songbirds cross the Mediterranean. Maximum prey, maximum availability. But what the adults do before the eggs hatch is genuinely unsettling. They begin catching migrating birds and storing them alive. The flight feathers are clipped so the bird can't escape. Then it's pushed into a rock crevice in the cliff face, held there, still alive, waiting. When the chicks hatch and demand continuous feeding, the parents pull fresh, living prey from the cliff stores on demand. Live prey stays fresh. Dead prey doesn't. The system works because the adults are preparing for a feeding demand that hasn't arrived yet. They're stocking a pantry against a future they can predict. Researchers studying animal cognition treat this as one of the most striking examples of future-oriented planning in any bird species. This bird can't get into beehives on its own, so it recruits humans to do it. In parts of sub-Saharan Africa, the greater honey guide approaches people, produces a specific call, then flies a short distance toward a known hive. It lands, waits for the person to follow, then moves again. It guides them directly to the bees. The person opens the hive, subdues the bees with smoke, extracts the honey. The honey guide moves in and feeds on the exposed beeswax left behind. This has been practiced for recorded generations in some communities, and researchers confirmed it's no accident. The birds only respond to specific traditional guiding calls, not random sounds. Use the right call, and they guide. Use the wrong one, they don't. The birds also track whether you're following correctly, fall behind, or go the wrong way. They redirect toward you. This isn't a bird accidentally leading the nearest person somewhere. It's an active, intelligent negotiation. The bird providing information, the human providing access, both getting what they're after. Neither routinely succeeds without the other. Most animals that use tools pick one up and apply it. This crow makes them from scratch. The problem: fat grubs deep inside narrow crevices in tree bark. Too deep to reach. Too narrow for a beak. A straight stick can't hook anything. The crow takes a twig, holds it still, and works the end with its beak, bending it until the tip curves at the right angle. A functional hook, made to order. But that's not even the most impressive part. It tests the tool. The crow inserts it into the crack, checks whether it's catching, pulls it back out, adjusts the angle, tries again. It evaluates whether the tool is doing what it's supposed to do, and modifies it if it isn't. In lab conditions, give them a straight wire and food at the bottom of a tube. No training, no demonstration. They figure out that straight won't work. They bend it into a hook. They fish the food out. They just reason. Their brain-to-body ratio sits alongside dolphins and chimpanzees. Researchers say these crows solve problems in ways that barely resemble normal animal behavior. In the city of Sendai, Japan, crows figured out a problem. They eat walnuts, but walnut shells are too hard to crack with a beak. Dropping them didn't always work. So somewhere in the Sendai population, one crow had an idea. It dropped a walnut in the road. A car ran over it. The shell cracked. The crow ate. Problem solved, except for one obvious issue. Walking into moving traffic to collect food is a good way to die. So the crows solved that too. They don't drop walnuts in the middle of the road. They drop them at pedestrian crossings. next to traffic lights. When the light turns red and traffic stops, the crow walks into the crosswalk, collects the cracked shell, and flies off. It waits for the next red if it needs another pass. These birds understand two distinct states, moving traffic and stop traffic, and they only act during the stop state. They use the crosswalk instead of the open road. This is a bird using urban infrastructure it was never designed to encounter, understanding how it works, adapting its behavior around it. The behavior has since been documented in other cities across Japan and at least one other country. The crows didn't just find a trick, they built a system. These birds aren't running on simple instinct anymore. They're solving problems, adapting, planning, coordinating, in ways that look disturbingly close to what we'd call intelligence. And this is just 15 of them. Which one got you? Drop it in the comments. And if that unsettled you even slightly, subscribe, because we've barely scratched the surface.